Yeah, it goes out. If you have a high A,
Yeah.
and there's someone else in there got a 90.
Yeah.
Oh.
That's different.
Yeah.
So you're in a tough class to suffer through that.
No.
What is it? What is it?
Business finance.
Intro.
You guys talking about saying something bad?
I'm taking it too, but dude, yeah, I'm taking it with.
Hope you guys are not talking about this class behind me like that.
Yep.
No, because this class
We were
is
waiting for you to come in the room.
Right.
I think I signed homework for this chapter.
Yes.
I did, right?
It's,
Have you guys started?
yes.
Yes,
It is very complicated.
because some of them haven't been put yet.
Yeah.
That's right, I have to, right. I think you can only start doing one question one,
And some of them, yeah.
right? And the rest of them you have not covered it, yeah?
Yeah, I mean, a lot of the questions, like, it has a, you have to fill
Probably
out
started
a chart,
everyone
like a table chart, and I don't know how that
Right.
works, so that was the,
I can talk about that.
okay, please do, because I was so lost doing it,
But only do question one.
pretty much.
Yes.
I gotta go down. Do we like pull it up, project it on the TV? The actual homework problem?
Sure, we can do it right now.
Yeah, let's do that, yes, please.
You want me to do it now?
Yes, please.
Question.
The only reason I questioned it, like,
Power?
Now don't tell me you don't know how to cut on the TV. Don't tell me you don't know how to cut on the TV.
Does the math do it from over there?
wait, is there?
I'm not as good as talking like you.
Is it?
Fire, but.
Yeah. Oh, there it
See
is.
there? I don't think there's a
We on the
remote here.
screen.
But
Yeah.
The files are inside the computer.
Yeah, I get it.
Is she?
oh, it's right here. It's okay.
No, but you gotta change it. Or you gotta set up where the.
Okay, so this is.
Yeah, I'm just like, I ain't wasting it. Because the first homework is on actually.
Y'all smile, y'all see what on candy
Wait,
cane.
I'm not supposed to do that.
It's on this side
As the
now.
computer started, you got something like
Oh, here we go.
Yeah, that's great.
Zoe's in the middle, I'm back.
Not because see myself.
Wait, you on candy cane?
You know,
Josh?
the first time I done this, I watched the video myself. I said, "Oh, that's me." And never realized how strong my accent was until I watched my own video. I mean, it's very interesting. It's like watching somebody else.
I feel the same way. Really. When I see myself on, or when I hear myself on the phone or something, it sounds weird.
Yeah.
Yeah, whenever I say I go, wait a minute.
All right. Okay. So about this, and the starting, and let's start. Okay. So we finished half of the chapter. Okay, half the chapter. Half the chapter. This first half is heavy. Okay, and the second half is less heavier. Less heavier. And so basically, we've been talking about student decision on the optimal input level. And the optimal L and optimal K, optimal labor input, optimal capital input, right? Okay, and we derived the condition. I showed you the graph how to derive that, right? MPL divided by MPK must be equal to PL equal to PK, right? Okay, that's one thing we learned. And also last thing we learned, another condition or formula to derive. What is that?
The grading documents.
Formula. So one formula we have learned, okay, to derive K star, L star. Okay, so we learned this. And we learned something else in last class.
Talking about the minimum of the LOT function. LOT. What? Tell me.
I'm trying to understand what you're saying.
Alright, I asked if you're talking about the LOT.
Oh, no, not that one. No, another formula.
MP goes up. MC equals what?
Remember? That's what we used to solve L star. This is a marginal benefit of hiring one more worker this is the marginal cost of hiring one more worker. We use that to solve question 1, part C. Just forget that. Taking notes. It's there.
It's here.
You saw it?
Oh.
Yeah.
Wow, okay, yeah, I see.
Promise
Okay.
to see.
So that's 2 different formulas, and we can use to solve K star and L star. Okay, so this is to solve L star. Can you replicate this one, come up with another one to solve K star? P
Times margin of profit and capital. Price capital.
Yeah.
Yes. Okay, so basically that's what you learned from the first half of the chapter 5. Okay, all these formulas is used to derive optimal capital and optimal labor. Okay. Alright, so today what are we gonna do? We finish the and this discussion of this decision. The second decision we're gonna talk about is what? What's the second decision we're gonna talk about? Optimal output. Q star. That's what we're gonna do. Okay? The procedure that I'm going to talk about this is very similar to the procedure I did for the K star L star. Okay? To derive the K star L star, and if you look at the formula here, we have this in addition to the parameters needed. We have this marginal product of labor and the marginal product of capital goods, right? How do you derive the marginal product of labor or marginal product of capital? How do you derive MPL and PK? What do you use to derive that?
Partial derivative.
Yes, it's partial derivative of what? Partial derivative of what function?
Leo.
What do you call those? What's the name of the function I'm talking about? What's that?
Column doesn't.
Production function.
Oh,
Production function. Okay, you guys know you just another name. The production function. So those MPL and PK are derived from production function, which is okay. So that's why at the very beginning of the lecture, when I talk about this decision, first thing I introduced you is production function, right? I show you what is production function looks like, what is MPL look like, what is APL look like, right? Okay, because that's what we use eventually to derive the formula. And we're going to do the same thing. So eventually I'm going to have a formula or mathematical equation to derive that. But to get this, I have to introduce you another function. But it's not a production function. Can you guess? Can you guess what the function will be?
Production possibilities frontier.
No.
That's what God said.
Assume.
I don't know.
It will be the function I'm going to introduce you. If you think about this from the manufacturer point of view, from the business owner point of view, and the business owner needs to know the relationship between the input and output. Okay, so that's on the production side. In addition to that relationship, there's something else. It's also very important to the producer.
Sales the product.
Selling the product. Well, here we assume the competitive market. So for the competitive market, they have to take the price, determine the market, and sell good at the price. But really, they don't have control over this because we assume we're in a perfect. So that price we have no control. So in addition to producing side, what other side is also very, very crucial to producing?
We're saying it's not price.
Huh?
You said it's not price.
It's not.
Cost.
Great. cost. Okay, when I produce 5 units, how much will be the total cost? So the function I'm going to introduce you right here is called total cost function. Okay, and we're going to use this total cost function eventually to derive another mathematical formula. Then we use that mathematical formula to determine the Q star. Okay. So I'm just going to use C of Q in a bracket, means this is an implicit cost function. Okay, this cost function can be anything. For example, could be this Q to Q, could be this form, and could be Q plus 2Q squared, could be that form, and could be this form, could be anything. When we do not know it, we just say this is an implicit cost function. Okay? So today's lecture, we're going to focus on that. Okay, we're going to, and talk about this cost function like we talk about the production function. Okay. So first, okay, so let me. Question?
Sorry, yeah, this is, we're in the output section.
Yes,
right?
we're
Okay.
trying to determine the optimal output.
Okay.
Okay, that's why I introduce you the cost function.
Okay.
And so we're going to use TC to represent the total cost. Okay, total cost. So eventually I'm just going to use TC to represent total cost. And I'm going to divide the total cost into 2 parts. Okay? And the first part,
It's a fixed.
Yeah.
Variable.
so you have learned this stuff, right?
Yep.
Okay, how much you remember?
Go there and teach it.
Total fixed cost
Mhm.
plus total variable cost. What is total fixed cost? Give me an example.
It's a number, it's one constant.
Yeah. Give me an example.
Something doesn't change, like your rent.
Yeah.
The something that will not change when you produce
Yes,
more and
right.
more, right?
Mhm.
Okay, so that's fixed cost. Like like rent will not change, right? What do you think about utility? Will be part of fixed cost. Will be part of variable cost.
Variable.
Rounds of production is dependent on.
It's a long one or short one, depends on.
Well, actually, it does not matter if we're talking about short and long run. Still, if you produce more, it's likely you're going to use more water and electricity, right? So as long as it changes as you produce more and more, then it belongs to variable cost, total variable cost. So everybody is clear about that, right? So I don't need to go into more detail. Okay. All right. So the next concept I'm going to introduce you is average cost. So we're going to use AC to represent average total cost, and that is equal to total cost divided by output. Okay. So if you look at the formula here in this section now, we're no longer using K and L. We're using the output level. We're not using the K and L in the formulas. Okay. So that is the average cost. Okay. And how about the average fixed cost? Will be just the average, will be total fixed cost divided by
Output.
output. Average variable cost will be equal to total variable cost divided by output. Okay. This is straightforward. Okay, then what will be the relationship among the three?
plus
A.
AC is equal to AFC plus ABC, right? Okay. Okay, so this is the total cost. This is a series of average cost. What the other costs I'm going to talk about?
Marginal cost.
Marginal cost. Good. Now you can teach this course. Okay, what is the marginal cost equal to? First, how do we interpret it? How do we interpret it by word?
Cost of producing one additional unit.
It is, say it in a complete sentence, in a really complete sentence, say.
produce 1 unit of product, how much cost will it increase?
It's additional total cost when you produce one more unit, right? Okay, so it's change of the total cost divided by the change of the output. Okay, so knowing my teaching style, after I introduce you those mathematical formulas, what's the next thing I'm gonna do? Graphs, good. So I'm going to draw the graph for the total cost, for the average cost, and for the marginal cost. Okay. Okay, so this will be the dollar on the vertical axis. Okay. And this will be the output level. Okay. So first, I'm going to introduce you the total variable cost. Total variable cost is a cost that's going to increase as you produce more and more. When Q increases and the TVC increases. And the shape of the TVC looks like this. Actually, I think it's a very fun curve, right? Okay, again, whenever you draw a graph, you want to interpret the shape of it. Okay.
That's the shape of what again?
This is TVC. Total variable cost. It increases. At the beginning, it's increase with decreasing rate or increase with increasing rate. Look at the graph at the beginning of the graph.
Increasing with a decreasing rate.
Increasing with decreasing rate and increasing with increasing rate. Why it looks like that? Why the total variable cost increases at the decreasing rate at the beginning? After you reach certain output level, if you keep increasing your production, and you're going to experience an increasing rate of total variable cost. Why is like that?
Resources become more expensive, apparently.
We assume the price of the inputs
Well,
are determined in the competitive market, so those PL, PK are really not changing. Okay.
Less efficient.
you reach capacity, I'm assuming? You reach capacity?
Elaborate on that.
If you've reached capacity for whatever it is, the equipment that you have to
Okay.
outsource in some way or figure out a way to mitigate that cost.
Remember when we talk about the curvature of the production function, we mentioned one key factor is if you have fixed scale, then you have fixed production potential. You have fixed capacity to produce. So that fixed capacity can only accommodate certain level outputs, right? And before you exhausted at that production potential, every time you employ more input, you're seeing the benefit. And the same idea applies here. So before you reach that production capacity, every time you increase the output, even though the total variable cost increases, but it increases at a lowering speed. So this is a sign that you are utilizing the production capacity right now. So you should keep producing, because even though the cost is increasing, but you increase at lower speed. But after certain point, after you exhaust all the production capacity, if you want to push it, workers already work 10 hours a day. If you want to, push them even further, the machine already running for like 16 hours a day. If you want the machine to run 24 hours a day, produce even more, then you're probably going to experience a breakdown of the machines. And if the machines break down, you probably have to pay money to get it fixed. And if the worker gets sick and they have to take a leave, then you have to find a substitute, and that's going to affect the total cost. So after you exhaust all the production potential, if you keep pushing, you want to produce more, you're going to start seeing an increasing rate of the cost. The cost is going to increase at an increasing rate because you're going to start experiencing some other level of cost. Okay, so that's why the shape is like that. Okay, good. So how about the total fixed cost? What total fixed cost looks like?
It's gonna be
How is
straight
it?
line.
Because you're not changing as you produce more, right? You're not changing. Okay. Now we know the total fixed cost, we know total variable cost, total cost, we just add these two. So when we add these two, what does it look like? What do you do? You have this horizontal line, you have this curved curve.
To move upward.
Yes, you're going to move this curve up by this much. Okay, so it's like you have this exact shape of the curve, you just
Oh, wow.
move up by this much. Same distance. And that will be the total cost.
And how does that happen, or why is that happening again? I'm sorry.
Okay, so we're trying to derive the graph for the total cost. Total cost is TVC plus this. So it's just total variable cost plus this distance, right? So you just move every point along the total variable cost by this much.
Oh, okay, I'm with you. I got you. I'm with you. That makes sense.
Okay. All right. So good. We know the cost, total cost, what total cost looks like. How about average total cost? Let me change this into ATC actually. Okay, what does average total cost look like?
It would be,
Still use the concept we talked about earlier. We have fixed the production potential, right? We fix the scale. So if we have fixed scale and we have fixed the production potential, before you exhaust that production potential, every time you increase, you produce one more unit, what's going to happen to the average cost?
it's gonna go down.
Should go down, right? At the beginning, should go down. And after a certain point, go up. So ATC looks like that. Okay. And ABC is below ATC, it also looks the same. How about the marginal cost?
J
It's also this way, right? Decreasing at first, then increasing afterwards. That's for the same reason. Because before you utilize all the production potential, every time you increase your production by your unit, your marginal cost of producing is going down. Okay. So if I put all of them together, that's what it looks like. Marginal cost is going to cross ATC, ABC at their lowest point. At their lowest point. Make sense, guys?
Because you want the marginal cost to be as low. You want the marginal cost to be as low as possible or something?
Not necessarily.
Okay.
Okay, so this shows you at a different output level what is your marginal cost, right? But which one you're gonna pick, we have not reached that part yet.
Okay.
Which Q we're gonna pick, we do not know yet. Okay?
Okay.
Alright. Okay, so that's the cost function I want to talk about. So basically, I introduce you what is total cost, what the average cost, what the marginal cost, and also their graphs. Okay. So now I'm going to erase this part. We're going to start derive the formula for Q star. Okay? So we're going to leave this graph here. Okay. I'm going to leave this graph. So how do we find the formula for the Q star? By utilizing the cost function. So we're looking for an optimal Q. So what? So what is the goal here for the firm? When we derive this, we mentioned again, what is the objective for the firm? Objective to goal.
Produce a product at the lowest cost.
Minimize the total cost or maximize the profit, right? The same goal here. What we want is maximize the profit, right? Are you guys with me? Okay, we want to maximize the profit. In order to find the optimal Q to maximize the profit, and we're going to utilize that universal rule that we talked about last class. What is that universal rule? I mentioned that no matter we're talking about decision by the consumer or producer or policymaker, if we want to reach the optimal decision, you always have to use this principle. What's that?
Maybe marginal benefit is
Margin.
greater than marginal cost.
Marginal benefit equal to marginal cost.
Oh, it's equal to?
Equal to.
Not greater than.
That's the principle.
Gotcha.
Not greater. Equal to.
Oh.
The optimal decision lies at when these two are equal. That's how we derived this,
Okay.
right? Marginal benefit equal to the marginal cost.
Oh.
That is the universal rule. So I'm going to ask you to formulate this for me. This side will be the marginal benefit. This side will be the marginal cost. So what are you going to write here? Remember, this formula eventually is going to be used to find Q. So Q must be of the variable in this formulation, not L star, not K star. So we're not going to see the variable K and L in this formula here. We're just going to have Q
Yeah.
as the only variable. So what is on the right side is a benefit, the marginal benefit.
Price times quantity? No.
What is price times quantity? That is the revenue.
That's your revenue, yeah.
That's revenue. What is the marginal revenue? Because here's left and right as a marginal, right? Marginal benefit will be the marginal revenue of producing one more unit. What is the marginal revenue producing one more unit?
I mean,
Say it.
it's the amount of revenue you gain after each.
Think about it. The marginal revenue means when you sell one more unit, how much money you get. What is that?
Mathematically, what is it?
Yeah,
Huh.
what is
Change
that?
in revenue over change in quantity.
What is that? What's the symbol?
Delta.
Nope.
When you sell one more unit, how much money you get? That is equal to what?
The quantity times price.
That's the total
Would be
revenue. That's
used.
not the marginal revenue.
Already said that.
When you sell one more unit, what is the increase of total revenue?
The price.
That's it. When you sell one more unit, the increase of total revenue just the price, right? You see, the mathematics that beautiful. When you figure out the answer is that simple. It's the price. What do you write on the right hand side?
Marginal cost.
Good. How do you find the marginal cost? Go ahead. You know it. Just say it. How do you find the marginal cost?
Change in total cost.
You take the derivative of this
Mm.
with respect to Q.
Oh.
How do you find this? You take the derivative with respect to K and L, right?
Mhm.
Now you have the total cost function. You take the derivative, then you have the marginal cost. Okay? Marginal concept in economics is the derivative in mathematics. That's the link between mathematics and economics. Every time you see a marginal in economics, that is a derivative of a function in mathematics. So we use the marginalism concept, we derive the formula. And in this formula, P here is a parameter, and marginal cost is going to be a function of Q, then we can just solve Q. And that Q is optimal Q we're looking for that maximizes the total profit. Is it clear, guys? This is not too hard, right? How about we do practice?
Yeah.
Okay. Actually, this section here is easier than the first one. Okay. So because we only have one variable. All right. So. CQ is equal to 20 plus 3Q squared.
What? Which exercise? Which? Don't worry about it. Don't worry.
I give you a cost function. Total cost function. What is the total fixed cost for this business? You're too fast. Wait, 新鲜. Okay, wait. I want everybody else to think about it. Have some time to think about it. Okay? But thank you.
Well,
What is total fixed cost in this function?
that's 20 because there's no variable changing it, so it's
That's
gonna
right,
remain constant.
So if I want you to ask you what is total fixed, $20, right?
Mhm.
What is total variable cost?
Well, do we have a?
You just said total fixed cost is 20. If total fixed cost is 20, what is total variable cost?
3Q.
3Q squared,
Uh-huh.
right? Because the sum of these two must be equal to total cost. Okay. And what is the average? Average variable cost.
Is that a derivative?
That's a question I'm gonna ask you. Average variable cost. What's the formula? I introduced you the formula. Average variable cost is equal to what? Jackson, what is it?
Oh no, he's
She said it, I did not hear it. What is it? What is average variable cost? No, I'm gonna ask you now. What is average variable?
Variable cost over quantity.
total.
Total
Variable cost. We're looking for average.
So total variable cost is equal to
Average. Total variable cost.
what is total variable cost?
20 plus 3.
See, I know you're somewhere else, that's why people pick you. What is total variable cost?
Equals total fixed cost plus.
No, here. What is the total variable cost in that function there? There's two terms there, 20 and 3q squared. Which one is the total variable cost?
3q squared.
So 3q squared, good. Okay, now what is average variable cost?
20.
Average variable cost
Okay,
is equal to the total variable cost divided by
100.
So average variable cost is equal to 3q squared divided by q, which is equal to? Okay. How about average fixed cost? How about average fixed cost?
Average fixed cost, it will be,
It's equal-
20 over Q.
Good.
Yeah.
Okay, good. Alright, so then we're okay with average cost. And next is a marginal cost. And the marginal cost is a what? Robert.
Change in total cost divided by.
Okay, how do we find the marginal cost from here? Mathematically, what we're gonna do? Mathematically, what we're gonna do with this to find this? Derivative. Okay, derivative. Okay, so we're gonna take the derivative of this whole thing with respect to q. Okay, what we're gonna do with 20 when we take the derivative? Disappear, right?
Gone.
How about what we're gonna do with 3q squared when we take the derivative? Now I want to ask you. When we take the derivative of this with respect to q, what do we have?
3Q.
Take the derivative of this with respect to q.
Okay, 6.
6.
Q.
That's it, right? 6q. Okay. Because imagine this new power should be 2 minus 1, right? And this 6, you guys know how do we get this 6?
Yes.
3 multiplied 2. Okay? Alright, so my MC is equal to 6q. So that's how we utilize the total cost function to derive the marginal cost. Alright? If I tell you the price now is equal to $12, then can you solve Q, the optimal Q? Yeah. Not very hard, right? Okay. Alright, so good. So mathematically we know how we do this, how do we solve this. And now we're going to put all this kind of like a calculation on a graph. We want to use a graph to do the calculation for us instead of just calculate the numbers. Okay, so now we're going to use this. So now I'm not going to give you numbers. I'm just going to give you the graph. Then you figure out Q star on the graph for me. Okay? So this is ATC, ABC, MC. With those locations, that means all those functions are determined. Okay. Now I'm telling you is this. Now the price. Well, in addition to MC, we have to know the price, right? The price is right here. You probably have seen this graph before, right? I mean, in another principal course. So on the graph, how do you find optimal Q? the Q star is at? What's the condition? P equal to MC, right? So where's the Q that will satisfy that P equal to MC?
Would be the intersection.
The point that
Intersect. P and MC intersect right here. Right?
Yeah.
Okay, so what would be the Q that make this happen?
goes down.
So this is the Q star you're gonna pick.
Alright, one second.
Straightforward enough?
Mhm.
Okay, good. Now we want to find the profit on the graph. We want to say, okay, this firm, if this firm is picking Q star, how much money this firm is going to make? So I'm going to introduce the profit function. I'm going to use this pi here. This pi here is not the 3.1416, that thing, okay? It's just symbol to represent profit. The profit is equal to two parts. Total revenue minus total cost, right? How much you made minus how much it costs you to make that much money. What is total revenue?
Price times quantity.
Price times quantity. Okay. Then how do we represent this total cost now? You have to, eventually we're going to show it on the graph, so you have to use the thing on the graph to formulate TC. We don't have the total cost in this here, right? But we want to find the area to represent total cost. How are we going to do that?
Can I?
Yeah.
The average total cost times Q star.
Times Q star. Okay, so now to formulate total cost, we're going to utilize a formula we had. Just now we said ATC is equal to TC divided by Q. Now another way of writing this is ATC multiply Q is just equal to total cost, right? Everybody follow me on that?
No.
Yeah, where did you get ATCQ from?
Okay, ATC
Okay.
is defined as total cost, right?
Right.
So if I move this Q to the left hand side, multiply Q on both sides, then you'll have ATC multiply Q.
Just rearrange it.
Oh, okay.
Rearrange the formula,
Alright.
and then we have that, right? So I'm going to replace PC with
ATC times Q.
ATC multiplied.
Alright.
Good.
Yeah, that-
Why do I do that? Then I can utilize this graph to figure out the area. Okay, now I want you to tell me which area represents total revenue, which area represents total cost. Brendan? You never know who I'm gonna pick, right? Okay, so which area represents total revenue? This total revenue is P multiplied Q. Where's P? P is right here.
times.
Q star is right here. So which area?
I guess that box.
Which box?
Yeah, that box.
Yes. This box here represents total revenue.
Big box.
It's a big box. But we want to see whether the total cost is even bigger or not. Okay, so how do we find the area represent this? This is total revenue, we already know what is total cost.
So bring your Q star all the way up to meet ATC,
Good,
and it looks like your total cost is gonna be more than your total revenue.
that's right. Then this box here would be the total cost, right? Then what this area is,
Your loss.
Profit.
your loss, negative profit. Because your ATC is above the P. Okay, so P minus ATC multiply Q star. Since this case P is less than ATC, you have a negative profit. Okay. This formula I just introduced you is called economic profit. Economic profit is equal to total revenue minus total cost. And in this situation, economic profit is equal to, economic profit is negative.
Yeah.
You lose. Okay.
What is this? Oh no, is that CP?
Which one?
Oh, I got it.
It's not CP, I'm sorry. It's bracket, P
Oh.
minus ATC. Yeah. I know my handwriting can be messy.
So pretty much ATC is that whole box, but it's that little area that represents the loss, right?
This area represents that
Yeah.
loss, that's right.
So it's, obviously if it's below P, then it's gonna be a gain.
That's right.
Okay.
Alright, so in addition to this profit, I'm gonna introduce you another concept of profit. Chase, do you remember?
So that one was economic profit.
This is my economic profit. Do you remember what the name of the other profit, Chase? Do you remember?
From when?
2 years ago?
2 years ago?
Oh, maybe 1
I
year.
can't say that, dude, I'm sorry.
Operating
Operating.
operating profit.
Doesn't remember this.
I'm sure it was.
And this word here is very descriptive. Operating profit. Okay, operating. Because it will only take into account of operating expenses. It does not include the total fixed cost. So the rent money, the equipment spending, not included yet. I only include the daily expenses. Only include your wage, the cost of raw materials, utility bills. Only those are taken into consideration. So only total variable cost is taken out from the total revenue. Okay? So again, total revenue is P multiply Q star. How do we represent TVC now? Total variable cost. Look at how we represent total cost. Just kind of replicate that. How do we represent total cost? It's ATC multiply Q star, right? Now how do we represent the total variable cost? The same way. Average variable cost multiply Q star. Okay, for the same Q star, where is average variable cost? You draw the Q star to the average variable cost curve, right?
So it's gonna be box, right?
Is it here?
Yes.
What now?
We're trying to find
Average variable
Yeah.
cost. cost when Q is equal to Q star.
ABC.
Yeah.
You're right, right.
Yeah.
Is it right here?
Yes.
I see you guys look a little bit tired with all this, but I'm so so happy most of you are still with me. So to give you a little break, I'm gonna tell you a joke. Just
Alright.
okay. I recently went for meditation and learned this joke. You may not think it's funny, but I think it's very funny. Okay. Okay. You guys know Dalai Lama, right? Okay, Tibetan
His
Buddhist.
Holiness.
So he created this joke. So the first half of the joke is his joke. Okay, the joke is he went to in New York City, he went to a hot dog stand. He wanted a hot dog. Actually, Dalai Lama eat meat. Okay, and once in a while, not all the time. He went to a hot dog stand. He asked the owner, "Can I have a hot dog?" And the stand owner said, "Okay, we have a lot of choice. You can put pickles and onion stuff on it. A lot of different things. What do you want there?" And Dalai Lama said, "I want one with everything." You guys not laughing? Okay, that's kind of transcend, kind of transcend way of saying one with everything. That's
Oh, one with everything. I
one
got
with
I
everything.
get
One
it.
one with everything.
you. I'm
Okay,
with it.
so that's Dalai Lama's joke. Okay, you guys
I'll
need
just
to
slow
read. All right. Okay. So this another Tibetan Buddhist kind of utilize this joke, extend the joke a little bit more. Okay, is that so? The joke continues. So after Dalai Lama got this hot dog, then he handed $20 to the owner of the hot dog stand, and he's expecting something back, some change. But the stand owner does not give him anything back. And so eventually Dalai Lama asked him, "Why don't I get something back? I don't think it's that expensive for hot dog." Then the stand owner looked at him with this stern look, says, "The change has to come from within." So you get this one.
I'll look for it.
All right. So just want to wake you up. I thought it was a very funny joke.
Where's you at?
Good. Okay. Got some fresh air in your brain. Once in a while we need laughters, right? Okay. So now we. Okay. So now we have found this ABC. So this part here represent what?
Operating cost.
Total variable cost, right?
Can you explain that part again? 'Cause
This part here.
yeah,
Okay.
like the point and everything.
Okay. So we need to look for ABC, right?
Okay.
Okay. How do we find ABC? ABC is right here. And this is the Q you're going to produce. So you draw the Q to the ABC, and the corresponding point is average variable cost for this Q.
Okay.
That's how you find the ATC. You just draw the Q up to ATC and find the corresponding point. Right? Okay. So now we know this area here is
Total
for the variable cost, and what is area that is representing the operating profit? Operating profit.
It'll be
That's small, right?
yeah. Yep.
Is this?
Yep.
Is it positive or negative?
That's a positive.
It's positive.
Yeah.
So in this case here, you have operating profit which is positive, but you have a negative economic profit. Okay, now you may ask me, why we want to differentiate these two profits here? Why do we want to differentiate? Okay, there is a reason for that. Because we talk about the short run, long run. The firm's decision may be different in the short run, long run because they have different concerns. In the short run, you're not going to get those fixed costs covered, right? So the cost of the building, the cost of buying all this equipment stuff, it's not going to get covered in a very short period of time. So in the short run, you're not concerned about the total fixed cost. You're only concerned about whether your daily expenses is covered by your revenue.
Right.
So in the short run, you're going to look at operating profit only. As long as this is a positive, and you're willing to keep running the business.
Right.
But in the long run, you want every bit of cost to be covered. So in the long run, you want to include the total fixed cost. So you want this one to be positive. So that's why differentiate these two concepts of profit, because operating profit determines your action in the short run. Economic profit determines your action in the long run. So in this case, what is firms going to do in the short run?
They're gonna keep operating.
Okay, how about in the long run?
They will not.
They will leave.
Yeah.
They will leave this industry. Good.
Wait, so operating cost or operating profit is for short run, and what's the long run?
Economic profit.
Is long run.
Yeah.
Okay.
Yeah.
First moved in.
Is everybody with me here on this? Economic profit is used for the long
Makes
run.
sense.
Does that mean in the short run, the operating profit has to be
Positive. In
so
order
that
to
the
keep
company
running.
will continue?
That's right. That's right.
But they just can't cover their.
Fixed
Their
cost.
costs.
So that's not your concern. Yeah. Robert,
So if the economic profit was positive, then they would stay.
they will stay in the industry in the long run. Yeah. Okay, good. So that's the case in this example here. In this example, you're going to keep running in the short run, but you're going to get out of the industry in the long run.
I think that explains a lot of the homework then, because a lot of the questions in the homework had to do with, you know, average variable costs and all that.
That's right, that's
so,
right.
I think that'll be good.
All right. So now I'm going to keep the cost function. So which means average total cost, average variable cost, marginal cost, all this curve remain the same. So the characteristic of the firm remain the same. Cost curve remains the same, but now the market has changed. Market has changed, and there's less competition. So since there's less competition, the market price of the goods has risen. Okay, has risen. Has to risen to what? Has to risen to okay.
Why the price will increase?
You have less competition. Less competition. So in a sense, your supply has shifted to the left. Even the supply shift to the right, the equilibrium price goes. All right, so now, where is the optimal Q?
It's there.
Where?
The intersection.
Where?
Let's see.
It's right here, right?
Yeah.
So everybody's clear how to do that, right? Now, what is you guess on whether this firm should run in the short run or long run?
Both.
They should both. So which means the economic profit and operating profit both are positive. How did you reach this guess?
Because you draw a line at the bottom of the average total cost, it's been positive.
Because now the price is really, really high. It's higher than the lowest point of ATC. Right? So if you do this calculation here on the graph, you will see both will be positive. So actually, the cutoff price is right here. So I'm going to show you two cutoff prices, okay? One cutoff price is right here, P1. And the other cutoff price is right here, P2. In the first scenario, the market price is in this range, right? When it's in this range, you're gonna have a positive operating profit but a negative economic profit. So when the market price of this good is moderate, it's neither too low nor too high, then you're going to run in the short run, but you're going to get out of the industry in the long run. You guys with me here?
So between P1 and P2,
That's right.
and they are the lowest point of ATC and ABC.
That's right.
So the difference between two prices.
They will in the short run but out of the long run.
Out in the long run. That's right. Okay. And you can derive this by showing the graph like we did. So when the price is greater than P2, less than P1, you're going to run in short run only. Okay. What if the price is bigger than P1? And the market price is good, is really, really high.
Be worth your while.
You're going to keep running in both short run and long run.
Yep.
Run in both. How about when the market price of goods is really low, is lower than P2, we're going to do,
Short.
you're not even going to run in the short run.
Shut down.
Completely shut down.
Should.
Not run at all. Okay, so these two cutoff values are really, really important. Can you tell me what is the characteristic of this cutoff value, P1? What is the characteristic of this cutoff price, P1? So at this price, actually what happens?
Start making economic profit, anything above that volume.
At P1, the economic profit is 0. Economic profit is at 0. Because the price eventually is going to be exactly equal to the ATC. So P1, we call it break-even point. You break even. Economic profit is 0. The total revenue just covers the total cost. Break-even point. And the second cutoff value, what is characteristic of that? What is equal to 0 now at P2?
Your operating profit.
Your operating profit is equal to 0. So any price below that will make your operating profit negative, so you're going to stop running. So we call this P2 here is a shutdown point. Any price that is lower than that, you're going to shut down your business.
So is this graph kind of used for I don't want to say predicting, but
Yes,
Oh,
you can just use this predict. So you don't need numbers. As long as you know where the price is located in relation to this cost curve, then you can determine what this firm is going to do in the short run and the long run.
so it is mainly used for like predicting, like whether.
What you're going to do in the short run and the long run. That's
Okay.
right.
What you really are doing in real life is
Yeah,
adding up the liability
Yeah.
and
that's right.
every always cost. And you
That's
see
right.
loss mitigation
Mm-hmm.
Yeah.
is green and red.
Yeah.
Okay.
Mm-hmm. All right. Okay. So, oh, good. We're almost done here. And okay. So, one last thing. Okay. One last thing from this one. So you already know what is economic profit, what is operating profit, what is break-even point, and what is shutdown. Okay. And you learn that I'm going to erase all this part here. So we can be free of this. So you learn this. This is the condition we derived, and we use this to find Q star, both mathematically and graphically. Okay? And if you look at this formula here to determine Q star, you really only need to know the price and the marginal cost, right? You really don't need the average total cost and the average variable cost, right? So now I'm just going to pretend the other one does not exist. Okay, so I'm just going to leave marginal cost right here. If the market price is right here, P1, and we know you should produce Q1 star right here, right? If the market changes, market equilibrium price changes to P2. Based on this, and you should know the firm should produce Q2 star. Agree? So as long as you know the market equilibrium price, then you can utilize marginal cost to figure out different output, optimal. So what is this relationship? Is this some relationship you have learned before? What is here? What is this? You know what?
Price and quantity. Sure.
What is a relationship that actually we utilize marginal cost to describe?
Like, are you asking like if this goes up and this goes down? Is that what you're asking?
Okay.
Demand.
What I'm asking here is, okay, so by simply just using this marginal cost, okay, if you give a different, a single market price value, then we can find an optimal output provided by this form, right? If you give another price, we can find it. So the marginal cost, in a sense, describe a relationship between this and that, right? Is there something we have learned before? Also describe the similar relationship. Demand and supply. Market price, quantity. Quantity provided by the firm. This is the quantity produced by the firm, that's the quantity supplied to the market. Here we talk about producer. Producer is going to produce this much, and so they're going to supply this much quantity to the market. So, in a sense, this marginal cost curve actually describes the relationship between the market price and the quantity supplied by the producers.
Can you say that again?
Okay. This marginal cost curve is utilized or it describes the relationship between the market price and the quantity supplied by the producers. Right? This is the optimal quantity that's going to produce, and after it's produced this, they're going to provide in the market. That's the supply, right? That's the supply side.
Right.
It's not the quantity demanded by the consumer, because we're not talking about consumer at all here. We only talk about the supply side, the producer side, right? So you guys with me here? So this actually is, this relationship we're talking about actually is a supply relationship.
Yeah, makes
Right?
sense.
Okay. Actually, this is where the supply curve comes from. where does supply curve come from? At chapter 3, we learned supply, but we did not talk about where the supply curve come from. Supply curve come from the individual firm's marginal cost.
Because if it was the consumer, it'd be like marginal benefit instead of marginal cost.
And we also talk about actually how the demand is derived when we talk about chapter 4, remember?
Right.
Yes, okay, so from chapter 4, consumer theory, we derive the demand. Now from chapter 5, producer theory, we say that's how we derive the
Right.
supply. Yeah,
Okay.
that's where the supply, how the supply is derived.
Awesome.
Okay, and one last thing here. Do we consider all of this as part of supply or only part of it? We know the supply curve come from here, but is it
It's part
all
of
of it or part of
I think it's part of it.
it? It is part of it. Which part of it?
It's gonna be the,
Which part was gonna cut out? And why are we gonna cut out that part?
because we're gonna cut off the curve part because.
Which part?
The curve, where it starts to,
The lowest
yeah, the
level
lowest.
of the level of the lowest point.
Come here, show.
Uh-oh. Yeah. Bless you.
Sorry.
Okay. Xian suggests that this part we need to cut out.
I agree.
And I agree with her too. But is it the only part that we're going to cut out? Is there something else we also need to cut out?
You mean
In addition to this part, we're going to cut out, we probably need to cut out even more.
because that part of the marginal cost?
The top part of P1.
Yeah, there's part here we need to cut out as well.
Is that
Wait,
because
Anything
marginal
below,
cannot
anything below your operating,
Anything below
operation costs.
what?
Oh, economic.
economic cost?
So it'd be A,
Below
so anything above.
which point?
Operating profit.
No, it would be economic.
Oh yeah, the operating
You
profit.
do, you do.
Okay, so where is it? Where's that point? Where is the point that's cut off?
So is it the upper
Below
part
the
or? It could
AVC.
be either, because
The point
Was C2 your operate?
We're going to add ABC,
below,
ABC back.
yeah, AVC below everything.
Well,
What do we talk about this point here?
You're shut down, so you
What does it
can,
mean? Any price lower than this, you're gonna shut down, you're not gonna produce. So if I say I give you a price which is equal to right here, are you gonna produce this much?
No,
No, you're gonna produce 0. So this part does not really, you're not gonna produce anything if any price is below this. So we need to cut out all this part out. And so the things that is the supply curve is from here to here. And that's where the supply curve comes from. It's the lowest point of ABC above. The part of marginal cost curve that is above the lowest point of ABC. Because when the price is above the shutdown point, and you're gonna produce. Okay. I'm so proud of you with all this concept. You've been with me very well. So good work. So on Thursday we'll finish.
Right? Are you so excited?